Alright, it's time for the solutions for the practice those function properties assignment that you got while I was gone and you had the sub. And so the whole purpose of this is just so you can practice writing down the properties of these different functions. So for example, on number 1, we have this function here. It's just a line that's going down. The line goes left forever and right forever, so your domain is going to be from negative infinity to infinity. The line goes down forever and up forever, so that's your range, which is the y values. Your x-intercept is going to be right there, which is the point negative 4, 0. Your y-intercept is right down there, which is the point 0, negative 5. This line is never increasing. It's always going down. So this one is decreasing everywhere, which means it's increasing nowhere. And if you ever can say everywhere, you do from negative infinity to infinity. My function is positive when it's above my x-axis, so that's from negative infinity until you reach negative 4. Oops. And it's negative thereafter, so from negative 4 and to the right, it is negative, so that's from negative 4 to infinity. Your end behavior is always going to start the same way. And sorry about that insanely loud ringing noise. Of course, I set reminders for myself to do things, and then I can't do them. Alright, your end behavior always going to start this way. As x goes to negative infinity, your function is going to do what? Well, it's going to keep going up and up and up and up forever, so it's going to go to positive infinity. As your x approaches positive infinity, that is, as you go right forever, the function keeps going down and down and down forever, so it's going to approach negative infinity. And when you get the average rate change over the interval from negative 5 to 1, negative 5 is over here, and 1 is over here. So you have to figure out those points. You get the point negative 5, 1, and then you get the point 1, negative 6. And you get your y's over run. One way you can do that is subtract the y's, so 1 minus negative 6. And then you get the run, you subtract the x's, so negative 5 minus 1. Notice I did 1 minus 6, and then 5 minus 1. Make sure you do that in that order, and then I'll get you your answer. You'll get 7, and at the bottom you'll get negative 6. So we're looking at negative 7, 6 for our average rate of change. And let me see, hold on one second. Oh, that's really interesting, because our average rate of change should be what's in the function, which is negative 5/4. And so what's happening when we picked our points here, they're not actually on those exact intersections, and so we're off a little bit. But your average rate of change should always turn out to be what's in front of the x on your function assignment. 2. Domain is just how far left and right it goes. It goes left forever and right forever, so my domain is from negative infinity to infinity. The function goes down forever and up forever, so my range is from negative infinity to infinity. It has 3 x-intercepts at these 3 locations. They're the point negative 2, 0, the point 0, 0, and the point 3, 0. And we have a y-intercept just right there in the center at 0, 0. To figure out where it's increasing, when you split it up into the different sections where it's going up and down, on this first section here it is going up, so that's an increasing interval from negative infinity until we reach that x value there of negative 1. And the next interval where it starts going up again starts at 2 and continues on forever to the right. So it's going to be 2 to infinity. Make sure you put that u in there. It is decreasing from negative 1 to 2, and that's the only section where it's going down. This function is positive, as in above my x-axis on 2 sections right there, and on the right side. So between these x values there, negative 2 and 0, it's going to be positive, so negative 2 to 0. And the next interval starts up again at 3 and continues on to the right forever, so 3 to infinity. It is negative before you reach negative 2, and it's negative from 0 to 3. So those are going to be from negative infinity until you reach negative 2. And the next part goes from 0 to 3. And the left end behavior always starts out the same. As x approaches negative infinity, what's your function do? Well, your function keeps going down and down and down and down, so it goes down to negative infinity. There's nothing stopping it. The next one always starts the same. As x approaches positive infinity, what does your function do? Well, your function keeps going up and up and up and up and up without stop, so it goes to positive infinity. And this last part, we need to get the average rate change from negative 2 to 2. Well, negative 2 is over here, and 2 is right here. So we have this point here, and then this point down here at the bottom. So we have the point 2, negative 4, and the point negative 2, 0. So you want to get your rise over your run, you can do 0 minus negative 4, and then on bottom, negative 2 minus 2. We're going to get 4 on top, negative 4 on bottom. That's an average rate of change of negative 1. So that's going to be our bottom part down there. Alright, moving on to 3. Again, your domains, how far left and right it goes. The function goes left forever and right forever, so it's going to be all real numbers. I'm going to do the fancy R. Your range is not going to be that. Your function, the lowest it goes is down here at this asymptote of y equals 0. And so that's my lowest y value, 0. And it goes up from there. So it goes from 0 to infinity. The x-intercept actually doesn't exist. It never ever crosses that x-axis, so there is no x-intercept. There's a y-intercept right there. That's the point 0, 1. Next one's asking where is it increasing. So go from left to right. Is your function going up or down? Well, it's going up, and it's going up everywhere. So from negative infinity to infinity, that's a hideous infinity, it is increasing. So it's increasing everywhere, it's decreasing nowhere. So you can put none right there. Where's my function positive, as in above my x-axis? Well, that's everywhere. So from negative infinity to infinity. If it's positive arrow, it's negative nowhere, so you can put none right there. Your left end behavior always starts the same. As x approaches negative infinity, what's your function do? Well, your function keeps getting closer and closer and closer and closer to this y value of 0. So it approaches 0. For your right end behavior, you can write as x approaches positive infinity. You always start with that. What's your function do? It keeps going up and up and up and up and up and up without bound. And it just keeps going up. So it's going to go to positive infinity. As the next part, you need to get the interval from 0 to 3. 0 is right here. 3 is over here. And so, it's looking like we need to go from this point to this point up there. This is the point 0, 1. And the one over here is the point 3, 8. So, subtract the y's. So you do 8 minus 1. And then subtract the x's. 3 minus 0. You'll get 7 over 3. And that's your average rate of change. And that's the whole thing. Oh, at least that's the whole one on that one. That brings us to 4. Your domain is all the possible values that your x can be. It goes left forever. It goes right forever. It's going to be all real numbers. Your range is a little bit different. It does keep going down forever, but it doesn't keep going up forever. It actually levels out here on the right side of a height of 2. So it goes down forever. That's negative infinity, but it only goes up to 2, and it reaches 2. It can be 2, so you're going to have a square bracket there on 2. And we're looking for now x-intercepts. The only part that even touches the x-axis is right there, and that's the point 0, 0, which is also going to be our y-intercept, because that's where my function crosses y-axis. The next part is asking where is it increasing. So go from left to right. Where is it going up? Well, we have this section and this section. The first section on the left starts at negative infinity, because it goes left forever, and it goes all the way until you reach negative 2. And then the next one starts here right at the center at 0, and it goes on for 2 more to the right. And so that's where it's going to stop increasing. The decreasing section is just going to be right there. So it's between these two intervals. So it's going to go from negative 2 to 0. Next one's asking where is it positive. Well, it's positive here, and then positive to the right side. Right there at the center, that has a y value of 0, so that's not positive. So we have to actually split it up. It goes from -2 until you reach 0, and square bracket on the -2, because right here it is positive. And open brackets at the 0, because right there at it, it is not, but really close it is positive. And forever to the right, so from 0 to infinity on the right side, it's all going to be positive. And it is negative, and here on just on this section, that's from -infinity until -2. Alright, and then we have our left and right end behavior. These are always the same. Start as x approaches -infinity. What's your function do? Well, as you keep going left and left and left, the function keeps going down and down and down without n. It goes to -infinity. And the next one, as x approaches positive infinity, what's your function do? Well, it keeps going constant right there at a height of 2, and it's going to stay at that, so it's going to approach 2. And the last part, what's the average rate of change over the interval from 0 to 4? So from 0, it's here, to 4, which is over here. So we're dealing with the points 0, 0, and the point 4, 2. Well, to get your rise, that's the difference in the y's, so we do 2 minus 0, and then 4 minus 0. We have our rise and our run, so that's 2 over 4, which is just 1/2, and that's going to be our average rate of change. And that's going to be the front side.